Good evening, class. We are looking at section 2.8, the derivative as a function. Okay, this is the last section of this chapter. We covered various sections. And in the previous one, we went over the derivative and rates of change. The average rate of change refers to the slope of a secant line, meaning we have 2 points on a curve and we come up with the slope of that line. As for instantaneous rate of change, we let Q approach P in a limit sense, okay? We let X approaches A, we let H approaches 0, all of them give us the same result. And then we have F prime of A, which is the limit of F of X minus F of A over X minus A as X approaches A, or the second definition, the limit of F of A plus H minus F of A over H as H approaches 0. You have to be familiar with both. The second one is used more often. Now, instead of F prime of A, we can say F prime of X. We can generalize that, class. Now, if we do that, we get to what is known as the derivative as a function, okay? So this was at a fixed point, namely A, specifically at A. We've done that. Now, if we make it in general, what happens? This is the slope of a tangent line. F prime of A is the slope of a tangent line at X equals A. This is the derivative function. So this represents, in essence, infinitely many different slopes of tangent line. It is not a slope of a tangent line until you fix the value of X. When you fix the value of X, becomes the slope of a tangent line, okay? So if we go with this one, I think it's very straightforward. You change the A to X. If by any chance you want to use that from time to time, you can. So what do you do if you want to use that? You keep the A intact, do not change it. When you're done with this, F prime of A will be a function of A. Your final answer is a function of A, change the A to X. You can also do that. So there are various ways of writing this. So there are different notations, okay? So if Y is F of X, we can say Y prime or F prime of X. We can say dy dx. We can say df dx. We can say d dx of F of X. We can say capital D of F of X. We can say capital D sub X of F of X, in which case we are telling the reader the independent variable is X, D sub X. That means differentiated with respect to X. And this is the differentiation operator, okay? A function is differentiable at A if F prime exists. It is differentiable at an open interval if it is differentiable at every number of that interval, okay? Now, of course, another notation, dy dx is the limit of delta y over delta x as delta x approaches 0. I can't emphasize this enough. It's very straightforward. And of course, if a function is differentiable, it is continuous, but not necessarily the other way around. So we want to find an equation of a tangent line to the graph of the function. This is the type of question we've seen in the previous section. So you really have a choice of finding F prime of A, namely F prime of 8, and come up with the answer. But what we want to do in this section, we want to find F prime of X first. We want to generalize it. And then we plug in 8. So ultimately, it's very similar to what we have seen. There's really not much brand new here, okay? So let's find F prime of X by using the definition, okay? So here's the definition, class. So X plus H, that means F of X plus H, that means replace the X with X plus H, and plus 1. minus f of x divided over h. Now, how do we take care of the business here? Again, I hope you realize quickly, if you were to plug in, you end up with 0 over 0. Is an indeterminate form. And the technique we have learned in the case of a limit, so we can handle it here. Multiplication by the conjugate. So that means change this negative to positive, put it at top and the bottom. Again, I can't emphasize this enough that as far as the denominator goes, you don't do anything. You just write them as a product. This, you put it in a parentheses, h in front of it. This is a minus b, a plus b. Each piece comes out, everybody. So what happens to the denominator? Nothing. You just write it as a product. What happens to the numerator? Each piece comes out. And so what you have here is 3x plus 3h plus 1 minus 3x minus 1. That's what you have. And so that is a very straightforward question. You get rid of everything, you end up with 3h in the numerator. So h cancels out. And you have the limit of number 3 over the brackets as h approaches 0. And now you can replace the h with 0. So let's see what happens when we do that. We keep the limit up to here. Now we drop the limit. The numerator is 3 and h changes to 0. So if I change the h to 0, this becomes 3x plus 1, which is identical to this one. We have 2 of those. So I hope you realize why 2 of those. Now I'm going to replace the h with 0. This becomes 3x plus 1, which is the same as this one. So that's f prime of x. Now, what is the slope? What is the pair? We need 2 things. We need the slope and we need the pair. Okay, what is the slope? You plug in 8 in here. I hope you realize 3 times 8, 24 plus 1 is 25. Square root of that is 5, 3 over 2 times 5, or 3 over 10. Plug in 8 in here. 3 times 8, 24 plus 1 is 25. Square root of that is 5. So the pair is 8 comma 5. And the slope is 3 over 10. So you put number 8 into this, becomes the slope. You put number 8 into the original function, becomes the pair 8 comma 5. Y minus y1 is m times x minus x sub 1. Plug in, you have the answer. I hope nobody has any problem with fractions and everybody can handle it. You can apply the 3 over 10 and come up with the answer. So from here to here, I don't believe any calculus student has any problem. Okay. All right. So what happens next? We are looking at the graph of a function. Okay, and we want to use it to come up with the graph of its derivative. A rough sketch will do the job. So how do we do that? We use the easy parts first. So what are the easy parts? If we were to look at these peaks and valleys, look at this one, okay? This point, it's a local mean. This point is a local max. This point is a local mean. I hope you realize at those points, that means corresponding to this point, okay, you have a horizontal tangent line. So at those points, peaks and valleys, the slope is 0. On the other hand, this part class is decreasing. This part is increasing, decreasing, increasing. I hope you remember the meaning of increasing, decreasing. I'm going to give you the definition, the basic definition from pre-calculus. The simplest way, increasing means if x gets larger, y gets larger. That's it. Decreasing, when x gets larger, y gets smaller. That's all there is to it. So with that being the case, where it's increasing, it acts like the concept of a line and a positive slope, and it's decreasing just like a line with a negative slope. So pay attention to what we have here. So if we have a relative max or mean, if we have peaks and valleys, f prime corresponds to 0. If we have an increasing portion, okay, f prime must be positive. And if we have a decreasing portion, f prime must be negative. So take a look at a few things. I want you to be concerned with A, B, C, never mind part B. I'm going to discuss it in a moment. So clearly A corresponds to 0, f prime. So remember, I'm graphing f prime. So I need to know the shape. So certain points will help me. A corresponds to what? 0. B corresponds to 0. C corresponds to 0 if I were to graph that. Now this portion is decreasing. Decreasing means if f prime is negative, that means below the x-axis. So just the rough sketch. Let me just do that by hand, and then I'm going to erase it, show you the better version of that. So if we were to do this by hand, okay, let me just show you, and then I'm going to erase that. So roughly, this corresponds to 0. This corresponds to 0. This corresponds to 0. Okay. Now, for this portion class, it's decreasing, isn't it? If it's decreasing, that means f prime is what? Negative. When f prime is negative, that means what? Below the x-axis. That's all. I mean, does it look good? Is it correct? If it's close enough, that's fine. Let me use a different color. Let me go with this color here. This portion, everybody, is what? Increasing. What does it mean? Above the x-axis. However, it goes up. We may not know how far it goes up, but it has to come back down because these 2 points correspond to 0. And then this portion, which is decreasing, goes down, and it has to come back up. Okay. And then this portion is increasing, goes up. It looks something like that. Of course, you really have to do a better job. It's smooth, something like that. But I hope you get the picture as far as the concept is concerned. I want to erase it and show you a better picture. Okay, so I'm going to erase this for you. Okay, but understand the increasing, decreasing part. That's the main thing that you have to be concerned with. Okay. And the next thing also, I'm going to explain that point in a moment. Okay. Let's first look at the graph. Okay. So those are the graphs, everybody. Okay. So this is the graph of f prime. Now, as far as this pair, I want you to know that they are trying to show a point. The point being what? If you pick a point and you do your best to draw a decent tangent line, and then that tangent line, you pick up 2 points and calculate the slope. See, they say m is roughly 3/2. Then, and this is at p is at 5. So 5, 3/2 will be on the graph of f prime of x. That's the idea behind that. Okay, class? So I hope everybody's following that. All right. We want to look at a few simple examples, starting with the simplest example one can come up with. We want to come up with the graph of a derivative for this case. I hope you realize it's a linear function. It doesn't matter it goes through 0, 0 or not. That's not the point. The point being, what is the slope? All you have to do, pick up 2 pairs, calculate the slope. Whatever the slope is, class, if the slope, let's say m equals 5, then y equals 5 is the answer. Let's say m equals -10, then y equals -10. A horizontal line is the answer to this question. Okay, so all you have to do, pick up 2 pairs. And by the way, the scale along the x and y axis are not the same, class. So clearly this goes through 0, 0, so that's one pair. Another one would be 1 and 3. I hope you realize this point is 1, 3, okay, class? And so you can easily calculate the slope, right? And the slope is 3, so y equals 3 is the answer. Again, the point being, anytime you have a line, calculate the slope, and y equals that is the answer. All right? Now, y equals 3 is the answer. How about this one? This point corresponds to 0, this point corresponds to 0, and this point, class, maybe I just, again, I try to graph this and I'm going to erase it. So let's see, let's go with the red one. Okay, so this corresponds to 0. Okay, so this corresponds to 0. And this corresponds to 0 right here. Now this portion is what? Increasing. F prime is positive, so it's above the x-axis. Looks something like that. This portion is decreasing, so it's below, and it has to come back up, class. And then it's increasing, and the other part also goes up, class. Okay. So again, let me erase that. We have those two pairs, and this is the graph. I hope it's straightforward, and they correspond to those points. How about this one? Over here, it's flat, so we have a 0. Okay, this is a horizontal tangent line. So at 0, we have 0. And then this portion, class, this is increasing. So for this portion is above the x-axis. This is decreasing below the x-axis. So there's really not much to it. Okay. So some basic graphs, if you can do, you're in good shape. A function fails to be differentiable under the following conditions. Okay. If we have a corner, or sometimes they call it a sharp corner, if we have a discontinuity, okay, because the limit doesn't exist, or if we have what's called a vertical tangent line, okay. Now, they also have a cusp. We don't worry about it in this text, and sometimes it's even difficult to even distinguish between a corner and a vertical tangent line. So I'm going to give you the definition for all of them in case anybody's interested in. And then we will look at a couple of simple examples regarding this matter. So the very first thing is a corner, also known as a kink. The graph of f has no tangent line at this point. The left and right limits are different, class. Okay, simply put. In other words, before even I put that up, in other words, this is a sharp corner. How do you draw a tangent line? Which way? Okay, that's hard to tell. If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, we fail to have a differentiable function. And then a vertical tangent line. If you take a limit of f prime as x approaches a and it ends up being infinity or negative infinity, that is called a vertical tangent line. The graph of a function has a vertical tangent line at the point a or f of a if and only if the limit is either negative or positive infinity. And as you recall, a vertical line, when we discuss the slope, we say the slope is undefined. That's really the idea behind that. So finally, this is called a cusp. And what it really means is that, again, it looks like a sharp corner, class, but there's a slight difference. It's hard to tell, and that is the limit. In this case, the number of interest is 0. The limit of f of x as x approaches 0 from the left and right are different. One is positive, one is negative infinity. So, okay. And that is the definition of a cusp. I have that again. You don't have to worry about it too much. I put it in there in case anybody is interested. Okay. So in short, a function fails to be differentiable if we see a sharp corner, discontinuity, or a vertical tangent line. All right. So if we want to graph this one, obviously sharp corners, not differentiable, and anywhere you see a sharp corner, it corresponds to a hole. So how would we graph this? It's very simple, class. You just imagine, if I'm looking at this piece, I imagine I have nothing else, and I am concentrating on this part and this part only. And if this is 1, okay, that means it ends at 1, and there is a hole there. But what is the slope for this one? You calculate the slope for this one. Let's assume the slope is, making it up, m equals -10. By the way, it's clear that it's a negative. So let's assume it's -10. So y equals -10. Let me actually draw that. I'm going to erase out. I really want to make a point here. And the point being, assume the slope is -10 and it's not. If this line continued, this is y equals -10. If it's continued indefinitely, this would be the answer. However, it ends here, right? So over here you have a hole. Oh, let me just put that back in. And that's your answer. I hope everybody can. Never mind the rest. Just look at that piece. If you can answer that piece, then you do the same thing with the rest of it. Piece by piece, you calculate the slope, you draw a line, and then you cut it where you must. It becomes a line segment. So for this part, there's a line segment, there's a line segment, and this one is also a half line. Because we don't know where it ends. If you think it ends here, you can put, oh, but it continues. So let's erase this again. Okay, let me just use the eraser. So you have to calculate this. To calculate this, we are going to put a bunch of pairs, assuming those are the pairs, class. You can calculate the slope. You have 2 pairs, calculate the slope. And whatever the slope is here, it's the same thing but positive here, okay, class? This is easy, okay? This becomes 1, so this is -1, okay? This becomes -1/2. This becomes +1/2. This becomes +1. This becomes -1. What does it mean? Just graph the following lines. Y equals -1/2. Y equals 1. Y equals -1. Y equals 1/2. This one, it ends here, you have a hole. It ends here, you have a hole, hole, and here's what you have. Y equals -1/2. So you are going to draw all those, and everywhere in each corner, you have a hole. All right, now we want to see where the function fails to be differentiable. So it's very straightforward. At x equals 0, we have a discontinuity. And over here, if you said it's a sharp corner, I'm okay with that, but it's a vertical tangent line. And I'll explain the difference just in a, dealing with the graph in a moment. But it's really a vertical tangent line, not a sharp corner. But as I mentioned, I'm okay with that. Also, when it comes to the second one, obviously, this is the discontinuity, x equals -1. And number 2 is a sharp corner. Now, if you compare this to this one, this clearly seems to have some angle this way, some angle this way. That's why if I want to draw the tangent line, I don't know how to draw that. But this goes vertically, if you will. So that, and they, if it's hard to see, so, you know, I understand. We're gonna look at a couple more definitions here. So let's take the derivative using the definition, okay? And let's plug it into this definition. So f prime of x is the limit as h approaches 0. F of x plus h, that means 5 times x plus h, and then plus 1 minus f of x, you put 5x plus 1. I hope you realize the hardest part would be the algebra if it is hard. So you have to simplify the numerator, and it simplifies to the following: 5x plus 5h plus 1 minus 5x minus 1. Everything drops except 5h, and then you can get rid of the h, and the limit of 5 as h approaches 0 is simply 5. So we are using the definition for the sake of a section. Same here, we want to write the definition. So as long as we can write the definition, we should be fine here. F prime of x is a limit of h approaching 0. F of x plus h, that means 2 over x plus h, minus 2 over x over h. As long as we can write this, I can't imagine having difficulty finishing that. Now, the next step is to simplify this. I hope you realize if you plug in, you do get to 0 over 0. So what is the technique? LCD. We are going to multiply by x times x plus h, everything, the top and the bottom. We've seen this type of limit. We've seen how to handle it. That's why we did those. Our algebraic technique says use LCD. So if I multiply this by the first one, x plus h goes away, becomes 2 times x. By the second one, x goes over, minus 2 times x plus h. The denominator, do not touch it. Just write it as a product. Now, of course, this is 2x minus 2x minus 2h. These two cancel out. We have only minus 2h. Now, the h drops. Now, if I replace the h with 0, I get minus 2 over x times x plus 0. Simply put, minus 2 over x squared. Okay, minus 2 over x squared. Let's practice more. We are going to put it into this definition. The limit as h goes to 0, f of x plus h, that means 7 times x plus h squared plus 4 minus f of x minus this expression over h. Now, of course, this is x squared plus 2xh plus h squared. We need to multiply it by 7. Okay. When we do that, we get 7x squared plus 14xh plus 7h squared. Now we apply the negative, we get negative 7x squared minus 4. As you can see, the first and the last 3 cancel each other. What is left in the numerator is this. You factor out the h. In other words, your next step is to write h, although I can take the 7 out, class, but I don't want to. That's fine. 14x, okay, plus 7h. Again, I can factor out the 7h. The reason I don't want to do that, I just want to get rid of the h, class. And now I'm going to replace the h with 0, and the answer is 14x. Needless to say, all of this takes a second in the next section, but we are using the definition. All right, so 14x is the answer. And the next thing we want to discuss is the higher derivative. That means the derivative of the derivative. So if we have f prime, that's the first derivative. If we have f double prime, the second derivative. F triple prime is the third derivative, and so forth. After that, normally we use a number and we put it in a bracket. So d dx of dy dx or d2y dx squared, that is the way we write this. Okay, sorry, just I gotta erase the hat. Okay, and so here's an example. We want to take f double prime. Again, I don't want to go through the process of taking f prime and then f double prime. Normally, when we get this, we do it by the method of the next section. But assuming we already have done f prime, I just want to show you the process of f double prime, how it's done as far as the definition goes. So let's assume we got this. So we are going to write f double prime is f prime prime. So that means when you go with this f double prime, this changes to f prime. Class, take a look. So if you want f double prime, that means you're differentiating this. So that means you put f prime here. So this is the only reason I'm doing this, because I want to show you, in case you go with the definition, how it looks like. So now put x plus h is here. Okay, 3 times x plus h quantity squared. Okay, minus 1, and then minus this expression. Again, this is x squared plus 2xh plus h squared. We've seen it many, many times by now. So we multiplied by 3. This is what we get. Okay. Now, most everything cancel out. Let's just show that. So 3x squared cancels out. Okay. Minus 1 cancels out. Okay. So you're left with this. Now, if you take the h out, you get 6x plus 3h. So, taken, some steps out. So again, the numerator simplifies to h times 6x plus 3h, and this, again, let me use a different color. This h cancels out this h. That's what we have, and replace it becomes 6x if we were to graph it looking like that. Now, one of the places that we have a use for this is in physics, and I just want to remind you, we will look at that later on, okay? And simply put, okay, given S of t class, okay, the first derivative is the velocity function, v of t. And now the second derivative is the acceleration function, okay? So one application of that is dealing with rectilinear motion.